ring and delay scheme notes program code. I already uploaded it to the device Arduino board. Here, I press this button, close it down, first button, and show this first LED is fixed, and show the rest 3 LED. 1, 2, 3. And then I turn it off, and the third key switch will switch on this LED. Turn it off, and the fourth will turn on this LED, 3 LED, and stroking this LED. When this LED is in this position, in next turn I use the main board. I press this button and it will continue to swoop down, and I continue to use this. In third position, go to second position, 1, same as this. This is how the IR infrared remove control the infrared encoding methods, and how I decoded it, the different types of IR encoding. And for my eyes, this transmitter IC for 0 bits, the pulse shape is this, and for 1 bit is this, and they are of time length 1.23 millimeter. They both are same. And some other else, I think for the brand Sony or Philips, they use the same time length for these 2 bits. But for others, I found here, you see, this is 0 bit. The time length is shorter from here, and while the 1 bit, the time length is longer. And here, the high level for the 0 bit is shorter, is only 1/3 of the total time length, and the 1 bit is 2/3 of the time length. And I divide it into 3 portions, and each portion, namely is delta, is 0.41 millisecond. And for this train of pulse, there is 12 pulse or 12 bits, and here is the synchronized bit here. This is the lower level, and then you go to the first bit. And for this transmitter, this is 10100011, and the last 4 bits are the data bits for recording the 4 key switches. So this 8-bit address bit address bit. Here 4 bits is data bit, and data bits for key number 1, the pulse string is like this, 2, 3, 4. Now the first method I use to decode things in my program is the pooling method. And in the pooling method side, the first things I missed to mention, there is here is the pilot bit. This is a long times high level. Here is 12 empty bits. 12 bits, the total time length is 14.76 millisecond. This is the falling edge from here to the falling edge of here of the synchronized bit here. So in the pooling method program, I need to identify these pilot bits first, and then I can start to getting this address and data bit. And in my pooling methods, I also use the interrupt functions and the timing to. In the interrupts, it can sense this falling edge and this falling edge, and once the time elapses between the two successive falling edge equal to this 14 or 15 milliseconds, then this was successive elapses time is identified as a pilot bit. Then after the interrupt, is stopped, and another input pins is used to detect the rest of the pulse. And during these times, I need to check. I put some points that I need to check the timing. This is the 0 time. Once the interrupt stops, I put it. This is the 0 time, and this is the first bit, and it is the bit 1 bit, and it is 0 bit, and every bit I need to take 2 measurement points, here, 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 here. The second measurement points will identify if this is 1 bit or 0 bit. If this is low level, there is 0 bit. All the same here, so you can count how many points I need to take the time measurement. And clearly, these 2 points are of time difference 400. Why is this 400 microsecond? Why is this? This is 0.41. There is around 400. It doesn't need to take it 410. It don't need so accurate. And the most important point is here, this edge. And from this edge to this first measurement point is 200. There is half of this. So these two values are constant for all the bits, for all the pulse. The most important point is I need to identify this edge, the times of these edges, and by calculation, it's just a very simple calculation. From here to here is 0.41 microsecond. From here to here is 1.23, and plus this, I got this value, and increased by 1.23. All these time values can be written down. This is the calculation value, and below here is the measurement value. How this come out? It need to be checked in after I write the program code. I've mentioned this. I use two LED. Actually, one LED can be success to do it, but I use two LED as debugging purposes. And here, with this 0 point time, 0 time, and the first checkpoint I also put it here is in this area. So this checking point will identify this is the lower level and this is the correct signal bit, and this point is 250. It's just an arbitrary value. And going to this axis, important points here. From here to here, from this to here is 200. And this value, I first choose this value in my program code. I use the debugging LED to detect if this high level reaches or not. And I put this value for the first bit. I've put this value 200, and I adjust it, let's say 119 first, and if it's low level, and then I adjust this delay time. This all are the delay time. I adjust it to 210. If it's high bits, then this critical point is 200 milliseconds. And then I can write down the correct value for this, etc. And for the second bit, using the same method, I get it 620, and having this value is the delay time from this point to this axis, and this 620 plus this delay time plus this delay time, etc. I get this time is 1.67 microsecond, and these are the exact time, these are the calculated time that I mentioned previously, and all these measurement can be written down. Watching, and if you like this video, please subscribe us and thumbs up